Hi, today we're going to use Minitab statistical software along with Minitab's Engage and Simul8 software to look at how we can solve some very challenging healthcare problems. So let's start with looking at an idea. Everything starts with an idea because we like to help people or encourage people to provide their ideas to the organization. In Minitab Engage, you can plug in your new idea just by clicking New Idea, put your idea in, it becomes an idea proposal that goes to a team that can evaluate it. So we have some ideas in just waiting to be evaluated. Once they go to the next step, the idea hopper, we can actually look at various ideas versus how easy they are and how valuable they are. So the bigger the circle, the more valuable the idea. And then we might have a very good idea, but it's hard and risky, as opposed to this idea down here, which is easy to implement and low risk. So that will take a higher priority. We can then move into the active stage of a project. Once projects are active, we might use Minitab's customizable dashboard in order to kind of look at what's going on across our organization in terms of our active projects. We can focus on things like financials and see how we're doing financially in terms of hard and soft savings over the year, or we can focus on specific areas of our business. Here, I'm looking at some healthcare projects going on. I've categorized them by what type of project they are, related to customer wait time or patient safety or satisfaction. We're following the savings as they go along, and we can actually look at the specific projects that fall into this category. So in our healthcare repository, we have projects going on regarding readmission, acquired infections, patients leaving without being seen. And today we're going to look at what's going on with our Reducing Patient Falls project. I can click this project and that will take me directly to Minitab Engage where that project is. So Minitab Engage allows us to look at all the important details around a project as well as use various tools such as process maps, simulation, value stream maps, brainstorming tools, FMEAs, and then all kinds of analysis guidance. So Minitab Engage allows us to basically use many of those soft tools that come with continuous improvement around brainstorming and mapping in order to solve our problems. In addition, Minitab Engage provides workflows that we might be used to. For example, here we're looking at a DMAIC project. So Minitab Engage has set up for me already the things I need in a DMAIC roadmap. So I'm going to start with project today. I see this project is going on, but right now I see that this project is actually on hold. I need to find out why. So I'm going to look further into what's going on. I am in the control phase of the DMAIC project. We see that right here. This project, like all other projects in my organization, started with an idea. So here was the initial idea proposal focused on too many patient falls occurring. And then we created, when we started the project, a project charter. Notice that a lot of information is shared across the project charter and project today. As we look at information shared across various forms in Engage, if I change something one place, so here I look at the project status and I move it to in progress, I will see that back at project today, that status has changed from on hold to in progress as well. So anything I change in one place will be changed other places. We also have things like financial data, team members, and the tasks they are trying to complete. Over in the roadmap, which came from a DMAIC roadmap, define, measure, analyze, improve, control, I can see ideas of what I should do within my project. These roadmaps can also be customized specifically for what your organization needs. So here I started with a project risk assessment to make sure that this project wasn't too risky. It had a very good chance of success. And then Minitab Engage Roadmap tells me it's time to graph my baseline data. In the measurement phase, I'm looking at my baseline data. And I can look at right now the number of falls relative to the number of patient days in a hospital. I see there are no outliers, so my baseline data looks good. Next, Minitab Engage tells me I should do a baseline capability. So I'll go to do a baseline capability in Minitab statistical software. I'm going to use Minitab Assistant for this, Assistant, Capability Analysis, just like Engage told me. And now I need to decide what kind of capability analysis I need to do. When I look at patient falls, I'm talking about an attribute kind of data. Each patient falls multiple times or not at all. So yes, no, they fall. And what am I counting? I'm either counting the number of falls or the number of falls per patient. If I'm not sure, these diamonds give me guidance as to what I'm looking at. As I read the guidance, I see that I can have more than one fall or more than one defect per patient. So I'm looking at defects per unit. So my guidance tells me I'm going to do a Poisson capability. Inside Minitab Assistant, now I'm filling out a form. And this is already filled out for me. I'm looking at the number of falls relative to my patient days. And I have a goal. I could have read this in my project charter. My goal is to actually reduce my defect level so that it's below 0.005. So I want less than 5 defects per 1,000 patients, or 5 falls per 1,000 patients. Am I meeting that goal? Let's find out. I'll click OK. One thing that Minitab Assistant will do is it will start out with giving me the direct answer. And I see that no, my defects per unit is not below 0.005 or 5 falls per 1,000 patient days. I'm not meeting my goal or anywhere close to my goal. If I hover over to various pieces of output, I get an additional amount of guidance. But most importantly, I see that right now my defects per unit is running at more like 0.00675, so definitely not below the 0.005 specification that I've sent, or my goal of no more than 5 falls per 1,000 patient days. I can also see some additional things. My data is relatively stable, and then I get a report card telling me that I am meeting the assumptions of capability, maybe a few questions or pieces of information I might need, but all of this tells me that my baseline data tells me I'm not capable, and I have a reason for doing this project. Now I can send these results back to Minitab Engage just by send, and now these results have been added right here to my Engage roadmap. So I can easily incorporate what I'm doing in Minitab statistical software over to Engage. Now I'm going to skip down. We've also done control charts and U charts of the baseline data. Now I'm going to skip down to the Analyze section. And here I'm using some brainstorming to decide how I might improve this, reduce patient falls. Brainstorming just requires people throwing out ideas, like things that cause patient falls might include incontinence. So I'm going to throw out this idea over here in my task pane. Poor lighting, and I've already done much of the brainstorming here, but as I throw out ideas, I can categorize them. So incontinence, for example, falls under a patient health issue, and poor lighting falls in the environment issues, and I can just easily drag and drop and move things around. I can also easily make things pretty by changing things like the fill. So I can also go from a fishbone diagram, if I want to, over into a CT tree format or a mind map format. Now I'm going to go back to the fishbone format. Okay, now I've got some ideas of what I need to do, and as we've thought about this, we put in an idea, gone through some possible solutions. In my solution implementation, I'm going to think about the solution and how I'm going to actually implement it in my organization. What we decided with the best way to implement a solution was to put together some best practices around patient falls and see if they have an impact on reducing them. So we want to identify the fall risk for each patient. We've got some protocols to do that, and then establish a protocol based on the patient fall risk. So by establishing fall prevention plans with each patient and their family, we will ideally reduce our patient falls. And now let's see if they were able to do that. So we put in our best practices in a basic prototype unit, one unit in our hospital. And now we'll do another capability, but this time it's a capability comparison. So going back to Minitab statistical software, I have some new data. It includes my best practice data. So now I've put my protocols in place, and I want to see if that did indeed reduce our fall risk, and in particular, make our falls less than 5 falls per 1,000 patient days. So I'm going to do a capability comparison or before-after capability. And once again, it's Poisson because I'm looking at defects per unit. So I have my before data, my after data, and how well did we do? Let's see. The other thing that Assistant often does is if we're not meeting an assumption, it comes up and says, hey, we're going to use a different type of chart here because of an assumption around the variation in your data. Is that okay? Sure, let Assistant make those decisions for me. And once again, my first front page of Assistant tells me my answer. My answer is yes, we did have a significant reduction in patient falls. They were reduced by 45% given the new protocols. That's phenomenal. And our after data shows us that 0.004, 4 falls per patient day is our new defects per unit, 4 falls per 1,000 patient days. And we can be 95% confident that our new fall risk is between 0.003 and 0.005, meaning we can be 95% confident that our patient falls are between 3 per 1,000 and 5 per 1,000. So we did indeed meet our goal of an acceptable defect per unit of 0.005. And we significantly reduced the patient falls by 45%. So once again, I can take this and add it to my project just by sending to Minitab Engage. We'll go back to Engage, and now we're getting ready to put in a control plan so that we can keep these changes in place. We also want to roll out these protocol changes to other departments in the hospital. And of course, there's resistance. So as I'm rolling out these changes to reduce patient falls, I'm getting some resistance from the emergency department. Specifically, the nurses there say there's no way they can add patient education into everything else they want to do because they're not meeting their goals already of getting patients through the emergency department in time. So now I want to do a little investigating of that because we do need to put these protocols for fall risk in place, and we have resistance here. One way I can do that is I can add a simulation to actually simulate what's going wrong. The reason why I might want to do that, obviously I can see what's going wrong when I actually go to that emergency department, but by adding simulation, I can put in some potential fixes to the problem. So what they're seeing right now is they have someone come, they assign them a bed. Once the bed's assigned, the nurse takes the patient to that room in the emergency department. They're in that bed. And then they're seen by a doctor consultant, a consulting doctor. After that, they might have diagnostics tests done or they might not. And then they are discharged and the bed is released. Once the diagnostics come back, we know what's wrong with the patient. We can then either send them on their way, send them off with the medication they need, et cetera, and then they leave the emergency department. So to see how the process is running right now, I'm going to actually run this simulation to actually show kind of how the patient flow works as is. And we know from what the nurses tell us that right now it's problematic. In particular, we're seeing patients build up in certain parts of the process, meaning they might not be released in time in order to free up beds and meet our goals. So we have a goal of 90% of our patients making it through into a bed, getting out of the waiting room in the emergency room within 4 hours. So we want patients to be able to be assigned a bed within a specific amount of time. 90% of them we want within 4 hours, which seems reasonable to me. I'm running to the end of my simulation. When we look at when we're ready to assign them a bed, they're in a queue. This is the one sitting out there in the waiting room. And what I see is that only 12% make it into a bed within the time limit that we've set. So the nurses are right, there's a problem here. What we want to do is look at what really could be causing the problem, first of all, and also what things we might do to solve the problem. So the nurse is saying, okay, we don't have enough staffing. What happens if we add a nurse? Are we going to get people through a lot faster? So I can choose nurse, it's my resource, and I see nurses are assigned in a shift-dependent way. So if I look at the shifts that nurses are assigned, there's a night shift and a day shift. The night shift, we have 1 nurse. The day shift, we have 2. How about if we add another nurse in the day shift? So now I have 3 nurses in the day shift. I'm going to rerun my simulation just by run. How does that help? Well, hovering over this, it hasn't changed really anything at all. I still have only 12% of my patient population making it into the emergency room, into their assigned bed within the time that we want them to. So adding nurses to our shift doesn't help. It also means nurses may have some time to help us with our patient falls practice, but let's put that back to our current number of nurses. We have 2 in the day shift, 1 in the night shift. We'll leave it like that. But we also see in our simulation that we have a little X up here. There seems to be maybe some backup waiting to be released. So it says, first of all, we have 35% of our patients just laying in bed waiting to be released, which requires a doctor to sign the releasing papers. It also requires that the diagnostic tests be done. And this particular step in the process is what we call resource starved. 20% almost are waiting for one of those things, either a consulting physician to release them or their diagnostic tests to be in there so they can be released. So what happens if we add some beds maybe to give us a little more room in here? We can do that. We currently have 15 beds in our emergency department. What happens if we move to 20? Is that going to solve the problem? That way it doesn't, we've got a little more space for people. Let's go ahead and go back. I added 5 more beds. Let's see if that helps us at all. As we run this, we kind of see that we're still being bottlenecked over here on the right side, which is the waiting for diagnostic tests, as well as a consulting physician to let us go. And going back to how long it's taking to actually get out of the waiting room and assigned a bed, we moved up a little bit by adding 5 more beds, but not much. We're only at 13% meeting our time goals of getting assigned a bed in the emergency department. So, all right, take 2, let's try something else. What about if we look at the diagnostic test? We know our problem is over here on the right side. Let's look at the diagnostic shift. What that actually is, that resource is looking at the specific time when diagnostic tests are run. And I can look at that under shifts, diagnostic shift. It tells me diagnostic tests are only run from 8 a.m. until 8 p.m. And so possibly the problem, part of the problem is we're not getting the results from the diagnostic tests in time when they come outside of the hours that we're actually running those, what we call our diagnostic shift, when those tests can actually be done. If we remove that requirement and we get diagnostics all day long, how does that affect us? So as I look at diagnostic tests, I can look at the resources required, and let's remove that shift as a resource, meaning we're going to just let diagnostics run all day long, or more importantly, all night long. Does that solve our problem? Do we get people in and out of beds fast enough? So once again, we run our simulation, and this will just take a minute as we go through a week to see maybe this is our problem. And how do we do? Well, now we see that we're up to 65% are making it in time. So we still haven't hit our goal of 90% being in time, but we've gone a long way by not limiting our diagnostic tests to a certain time of day. We've gone from about 12% that make it through in our goal, our stated goal, and to 65% are now assigned a bed within the stated amount of time. Now there's more work to do. There's more, maybe look at more staffing, look at whether we should add some more consulting doctors, more nurses, etc. But I think now it's time to stop, because I think we've gotten to the place that maybe we have a new idea for our next project. Our new idea for our next project is optimizing staffing and resources in the emergency department using simulation. So I hope you've seen how Minitab Engage, Minitab Simul8, and Minitab Statistical Software can all work together to really solve some of your biggest healthcare challenges. Thank you for joining us today.